of Engineering and Technology from the Department of Electronics and Communication Engineering. Today I am going to explain you about inverse Z transform from the subject of digital signal processing from the unit of discrete time signals and system in the frequency domain analysis. The first topic is inverse Z transform. Suppose if we are considering the inverse Z transform, what is inverse Z transform? If we are converting any signal from time domain to Z domain, so for that we had used the Z transform. Now if we want to recover the signal back from this Z domain, then we have to find inverse Z transform. So there are basically three methods to solve inverse Z transform. The first method is a long division or power series method. The second method is partial fraction expansion method, and the third method is residue method. So by using these three different methods, we will solve the inverse Z transform example. Now we are solving some example based on the three methods. So I am starting with this long division method. So the first method is power series or long division method. By using this method, I am solving this example. Find inverse Z transform of 1 minus 1 by 2 Z inverse upon 1 plus 1 by 2 Z inverse. Now you can see that in this example there is a not ROC is given to you. Right. So if there is a not ROC is given to you, then we will outline it as it is considered as quotient sequence, and if it is quotient sequence, then the answer will be in the form of u of n, or if we are solving by using power series or long division method, then the answer will be ranges from 0 to infinite, right? So how are we solving this example? 1 minus 1 by 2 Z inverse means numerator comes over here and the denominator comes over here. So 1 plus 1 by 2 Z inverse. Now you can see that the first term is 1. We have to find it as a 1. So for that 1 will multiply with 1. So it will gives you the answer equals to 1, right? And 1 by 2 Z inverse will multiply with 1. It will gives you answer as a 1 by 2 Z inverse. Now we will giving it as a minus term, so this 1 minus 1 will cancel out, so it will be 0, and minus 1 by 2 Z inverse in minus 1 by 2 Z inverse means 2 times minus 1 by 2 Z inverse, right? So its value equals to minus Z. Now over here the one rule will be there that if the term will be in form of plus, then the answer should be in form of plus, and if term will be in terms of minus, then the factors should be also in terms of minus. So over here, if we are taking Z inverse, so we have to use Z inverse only, right? So if I want to derive Z inverse, so 1 will multiply with minus Z inverse. So 1 into minus Z inverse, it will give you minus Z inverse. Now 1 by 2 Z inverse into minus Z inverse means minus 1 by 2 Z raised to minus 1, Z raised to minus 1 means it will give you the answer equals to Z raised to minus 2. Now over here we are applying plus plus because we are changing the sign of each, right? So that minus Z inverse plus Z inverse will be cancelled out, and the final term is plus 1 by 2 Z raised to minus 2. Now we have to find out this term which is 1 by 2 Z raised to minus 2. So for that 1 is multiplied with 1 by 2 Z raised to minus 2. So it will gives you 1 by 2 Z raised to minus 2 plus 1 by 2 into 1 by 2 means 1 by 4, and Z raised to minus 1 into Z raised to minus 2 means Z raised to minus 3. Minus minus means this 2 will be cancelled out, and this term will gives you the answer equals to 1 minus 1 by 4 Z raised to minus 3. So this way we can do the term up to 3 to 4 terms, and after that we will write in that plus dot dot term. So now from this we can write the answer like this: x of z equals to, what will be the answer? This is the final answer, right? So this is the answer of x of z. So what is the value of x of z? Its value equals to 1 minus z inverse plus 1 by 2 z raised to minus 2 minus 1 by 4 z raised to minus 3 up to infinite. Now you can see that from the equation of unilateral z transform, what is the equation of unilateral z transform? X of z equals to summation n equals to 0 to infinite x of n is raised to minus n. Right. In this term, if I am taking n equals to 0, then the term will be x of 0 into z raised to 0. Z raised to 0 equals equals to 1 and x of 0 equals to 1, then the answer will be 1 into 1 is 1. So you can see that the first term is considered as 1, means the value of x of 0 equals to 1. Similarly, if we are taking n equals to 1, then the term will be x of 1 z raised to minus 1. So because of that, I am writing inverse z transform of this directly. So what will be the inverse z transform? X of z will convert in terms of x of n, and the value of x of n directly we will taking the constants of this x of z. So which are the constants? The first one is 1, then the next one is minus 1, then the next one is 1 by 2, then the next one is minus 1 by 4 up to infinite. Right. Now where is the location of arrow? Arrow will be located at n equals to 0. So we will applying arrow below the n equals to 0. And if we are taking n equals to 0, then there is not a single term of z. So without z, the term will be 1, right? So this below this 1, I am putting the arrow. So this is your final answer of inverse z transform when we will taking the ROC it is greater than something, or the ROC will be not given to you, or the ROC is given to you like this. It is a crucial sequence. So if ROC is given like this, mod z is greater than something, or the sequence is quotient sequence, or the sequence is right-handed sequence, then we will apply this rule. And otherwise, if there is ROC is not given to you, then also we will use this rule to solve any example. So in this we will taking u of n as the input filter, right? U of n term means the range will be from 0 to infinite. So the answer, this answer will be in the form of 0 to infinite. So first term, below the first term I am taking arrow. So if I am applying this arrow rule, then the final answer of x of n will be like this. Now similarly, if we are finding same method, by using same method, if we are solving some another example for mod z is less than something. Now what is the less than something? If we are applying less than something, means it will consider as an anti-closure sequence. Now suppose here the rule is applied like this. If the anti-closure sequence is given to you, left hand sided sequence is given to you, or mod z is less than something is given to you, then we will solving it by using the method of anti-closure sequence. Now if I am taking anti-closure sequence, then how is solving this example? In this example you are given that to find z transform of this, but for this we have taken mod z is less than 1 by 2. Now you can see that the value of x of z is the same, but the value of the ROC is given differently as less than. So we are solving in the different manner. So how we are solving this example? This example will be solved by using the next method. I am solving this example like this. That numerator comes here, right? And the denominator comes here. But if we are solving for anti-closure sequence, then we will reversing the order. How the order will be reversed? So the first term will goes at the last, and the last term will comes in the first. So I am writing 1 by 2 z inverse plus 1. Now I want to find out the answer equals to 1. So which term will multiply with this? So 1 by 2 z inverse will multiply with 2 into z. So z inverse z will be cancelled out, and 2 will be cancelled out. So it will give you the answer of 1. Similarly, this 2z is multiplied with 1, it will gives you the answer equals to 2z. Right. Now I am changing the sign, so this will be the term. Now I am writing this value. So minus 2z, this one is minus 1 by 2z inverse. Right. Now if I am finding the value of this, then what will be the answer? If I am to find out minus 2z over here, then which term will multiply with this 1 by 2 z inverse? If I have to find 2, then I have to multiply by 4. So 4, 2 will be cancelled out, so it will gives you 2. The answer should be in terms of minus, so I am writing like this minus, and the answer will be in the form of z. So over here I will write down like this. Which term will be there? Z square minus 1 will gives you z, right? So it will give you the answer like this, minus 2z, and plus 1 is multiplied with minus square means I will write down minus 4z square. This one is plus plus. So I am writing like this, minus 1 by 2 z inverse plus 4z square. Now, if I am finding the value of minus 1 by 2 z inverse, so I have to write down minus 1 by 2 z inverse. So you can see that 1 by 2 z inverse will multiply with minus 1. So minus 1 into 1 by 2 z inverse will give you minus 1 by 2 z inverse. Now minus 1 is multiplied with 1, it will give you the answer equals to minus 1. Right. Now we are applying the rule of sign changing. So the term will be like this, these two terms will be cancelled out, so it will give you the answer equals to 1 plus 4z square. Now if we want to find out 1, then what will be the term? Over here the term should be 2z like this, right? So it will give you 1 plus 2z. This minus minus will be cancelled out, so the answer will be in this form. So from this you can see that what is the answer? X of z equals to 2z plus 2z means 4z minus 1 and minus 4z raised to minus 2. Right. Now this term will be up to infinite. Now from this, if I want to find out inverse z transform, what will be inverse z transform? The inverse z transform of x of z will give you the answer of x of n. Now you can see that what is the value of x of n? If I am taking the range from 0 to infinite, then the value of it will be in the form of constant. Then z raised to minus 1, z raised to minus 2 up to infinite, right? And if we are taking left hand side its equal, then what will be the term? Z raised to minus minus plus 1 means it will be in the form of z, z square, z cube like this. So I am writing the answer in this form. First term I am writing for n equals to 0. Before that I am writing for n equals to minus 1. Before that I am writing n for n equals to minus 2. So applying this rule, I am writing x of n equals to minus 1. Before that I am writing this 4. Before that I am writing this minus 4 up to minus infinite. In this you can see that in which term there is not a single value of z. In this term minus 1, right? So before below this minus 1 I am applying this arrow. So this way we can solve any example by using power series method, but using the Koshal and anti-Koshal method. If the sequence is in the form of Koshal, then I will take as it is form, and the answer will be is also in the as it is form, means we are starting from left part and it will give you the answer to the right side. So we are writing answer from left to right. But if the sequence is given to you in the form of anti-Koshal or more than less than something or in the left hand side plane, then it will convert in the form of, we will convert the denominator, order will be changed or it will be reversed, and the answer will be written from right to left. So this is the rule to solve any example by using power series or long division method. Now the next method is residue method. So next example is find inverse z transform of x of z equals to z square plus z divided by z minus 1 z minus 2 using residue method. Now how will solving any example to find out inverse z transform by using residue method? For that we have to apply the first of all we have to find residues for it. Now how will finding the residues? For that first of all we have to factorize the denominator. Over here the factors is already given to you for the denominator. So there is no need to find factors for this. But if factors are not given to you for this denominator, then you have to first of all find the factors for that, and then you will finding the residue of it. So factors are already given to you, so I will solve this example directly. In this first step is step 1. We are multiplying the original term x of z with z raised to n minus 1. So what will be the term? It will be considered as the z raised to n minus 1 into z square plus z upon z minus 1 z minus 2, right? Because this term will multiply with z raised to n minus 1. Now if I am applying this to this term, then the term will be x of z into z raised to n minus 1 equals to z raised to n minus 1 plus 2 means z raised to n plus 1 plus z raised to n minus 1 plus 1 means it will give you the answer as z raised to n. Divide by z minus 1, z minus 2. So we had just multiply with z raised to n minus 1 and then we had simplified this term, right? Now the next step is to solve this example using residue method. We are taking residues at which pole is located. So the first pole is located at z equals to 1. So I will finding the residue at z equals to 1. Means I am finding residue at z equals to 1 and then I will find out residue at z equals to 2. And at last we will adding these two residues. So directly we can find out its inverse Z transform. So if we are finding residue at z equals to 1, then what will be the residue at z equals to 1? In this formula, we will removing this particular term at which we are taking residue. So the term will becomes like this: z raised to n plus 1 into z raised to n upon z minus 2. And as we are taking residue at z equals to 1, so I am finding this value at z equals to 1. Now in this, I am taking z equals to 1. So what will be the term? 1 raised to n plus 1 into 1 raised to n divided by 1 minus 2, right? So the value is 1 minus 2 means minus 1 and this term will becomes equals to minus 1 raised to n plus 1 and 1 raised to n. It will becomes equals to 1, right? And 1 divided by 1 means 1. But 1 divided by minus 1 means minus 1. We can also write like this. This will be considered as 1. 1 raised to n will remain as it is 1. This one is 1. This one is 1, right? So 1 plus 1 means 2. So I am writing like this, or we can also take 1 raised to n as a common part. So 1 plus 1 equals to 2. So it will consider like this: 2 times 1 raised to n divided by minus 1. So its answer is minus 2 into 1 raised to n. Now similarly I am finding the residue at z equals to 2. Second part, second factor, right? So what is the residue at z equals to 2? Z raised to n plus 1 into z raised to n upon z minus 1 at z equals to 2. In this we had taken this factor because we are finding residue at z equals to 2. So I am taking the value as z equals to 2. So what will be the term? 2 raised to n plus 1 plus 2 raised to n divided by 2 minus 1. So you can see that 2 minus 1 equals to 1. And if I am taking 2 raised to n as a common part, so what will be the term? This term will convert like this: 2 raised to n. This term will be 2 raised to 1 means 2 plus 1 means 3 divided by 1. 3 divided by 1 means 3. So the overall answer is 3 into 2 raised to n. Now if I am adding these two terms, then I can find out the final value of x of n. So what is final value of x of n? I am writing over here x of n, final value of x of n equals to summation of these two residues. So I am writing like this: 3 into 2 raised to n minus 2 into 1 raised to n. This one is for n greater than or equals to 0, or I can also write like this multiply with u of n, because we are finding the inverse Z transform by using residue method for only quotient sequence. So at last this input signal will be multiplied with u of n. So this is your final answer. Thank you so much.